All right, so the first exercise we're going through today is exercise 1B, and that's on page 8 of your textbook. No, page 8, that's correct. Page 8. Apologies for the terrible handwriting. Page 8 of your textbook, and it's on constructing linear equations. So the idea is you guys have already learned about linear equations. How do we put that into word form, or how do we get equations from a worded form? So in general, the first step you need to do is you need to obviously read the question carefully. I'm not going to go through that too much. You guys the first thing you need to do is you need to identify what information you have. Identify the information provided, okay? So that's obviously the most important step. To me, the most important thing in maths, or the most important skill in maths, is being able to identify what information has been given to me, what do I need to find, and then how do I find it. That is literally the formula for every single math question, agreed? Awesome. So the first step is identify the information provided. If you want to copy down the steps, that's up to you. But as I go through the question and the example, please do copy that down. So step 1, identify the information provided. Step 2, identify the unknown variable. Unknown variable. Now, a lot of people just think it's X, Y, Z, whatever it is. I think it's extremely important to stress that you need to also identify the unknown variables units, okay? Now, obviously, you guys know, for example, I say obviously a lot. In year 10, year 9, whatever it is, you guys know, add centimeters, add meters squared, or whatever. You guys will know that. But as we move on to more complex mathematics, we also talk about rates. So, for example, kilometers per hour, in which case the solving or the way to get to that answer is slightly different. So it's important to also find the units as well. So identify unknown variable, including its units. Step 3, create an equation. So create an equation in terms of your pronumerals. And then step 4, solve. That's it. That is the formula for all constructing linear equations. Any questions? Great. Let's get into this question. So find the area of a rectangle, and you guys are going to be very impressed by our rectangle drawing skills. That was by hand. So find the area of a rectangle whose perimeter is 1.08 meters if it is 8 centimeters longer than it is wide. So what's the first thing I need to do? What's the first step?
Identify information.
Perfect. What information has been given to me? Perimeter is 1.08 meters. I'm going to write that out as P equals to 1.08 meters. Now, what else do I do? What else has been provided?
Know that the length is longer than the width.
Perfect. It's 8 centimeters longer than it is wide. So how would I write that in terms of an equation?
Is it
Yeah, go for it. Sorry, continue.
L equals 8 plus W?
8 plus W. So if we think about it in like numbers terms, 8 adding on to my width, so getting my width and adding on 8 gives me my length. Does that make sense or not really? Yeah, makes sense to me. Awesome, let's continue with that. Is there any more information that's been provided? Yeah. Any other information? Yeah. So that's step 2, awesome. Identify the unknown variable. In this case, we're going to be identifying the area of the rectangle, and that's going to be coming in handy later on. So we've identified the information provided, we've identified the unknown variable, now we need to create an equation. So we know the perimeter is 1.08 meters, sorry. What's the first thing I need to do before I continue? Something to do with, yeah? No? So we've got 1.08 meters and we've also got 8 centimeters. Our units are different, it's going to get very confusing. Let's just change them into centimeters. So what's 1.08 meters in centimeters? 108 centimeters, thank you very much. Please let me know if I am speaking too quickly. I do tend to speak quite quickly. So it's 8 centimeters longer than it is wide. What do you think I need to do next? Sorry? Awesome, create an equation. Do you have something to add to that?
Well, I divided it by 4 first, so I had like an estimated number of what it would be around.
Sure, okay, you could do that. So what'd you get?
27.
27, so it should be around 27? Sure, okay. What I think we need to do is I need to, create an equation, obviously. What's the formula that we would use to find the perimeter of a rectangle? Easy. So normally, I'm going to use a different color. So we normally have P equals 2L plus 2W. Make sense? Awesome, let's put our information in. We know that P, which is 108 centimeters, I'm going to take that away, write 108 instead. And by the way, I am expecting you guys to write this down with me. So 108 centimeters equals to 2 times L. What's my L? Perfect. So 2 bracket A plus W. So it's 2 times all of W, all of L. Sorry. 2 times all of A plus W, not just 2 times A plus W. So we need to include the brackets. And then we add 2W. I'm going to go ahead and simplify that. I've got 108 centimeters equals to 2 times 8 is plus 2 times W, 2W, and then we have 2W there. Any questions so far? No? I'm going to simplify that. 108 centimeters equals to 16 plus 4W. I'm going to add, sorry, not add, take away 16 from both sides. What's 108 take away 16? 92 equals to 4W. Now what? Sorry? 92 divided by 4, thank you very much. So I divide both sides by 4. So that's, well, let's write W on this side. What's 92 divided by 4? What's 80 divided by 4? 20. And we still have 12 left over, so 12 divided by 4 is 23. Are we done?
No,
Why not?
because we need to find the area.
Perfect. We need to find the area. Remember, we're finding, well, we identified the units of the variable. We're looking for the area, not the length of W or L. Awesome. So we know W is 23 centimeters. I'm going to write W is 23 centimeters here. If W is 23 centimeters, what is my length? 31 centimeters. Easy. I'm just adding on 8. So L equals to 31 centimeters. And then I find the area by multiplying them, because perimeter is L times W. So not perimeter. Area is L times W. And end up with 23 times by 31, and I get 713 centimeters squared. Obviously, you're not expected to do that off the top of your head, but that is the path that we followed. Do I have any questions on that one? Does this just seem like a little bit of an extension of what you guys did last year? Or does it completely seem very different? Very different? No? Okay. So that was constructing linear equations on page 8. We're going to move on to exercise 1C. So exercise 1C is actually on simultaneous equations. You guys did some of that last year, yes? 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 Lovely. Okay. So exercise 1C is on page 11. So what does it mean with simultaneous equations? Well, we're saying what values of x or y, whatever variables are there, what values do I have that give me the same answer? So let's go ahead and do an example, and then I'll explain in terms of a linear equation. So I've got 2x minus y equals to 4, and then I've got x plus 2y equals to negative 3. So that is the question. 2x minus y equals 4, x plus 2y equals negative 3. Did anyone tell me what are the two methods of solving simultaneous equations? Yes? Lovely. Substitution and elimination. I'm going to do them in different colors just so we can separate them. And the second one is elimination. Now, rule of thumb, this is not going to come up in a textbook, but rule of thumb is if you can substitute, generally it's easier. If you look at it and you're like, I can't substitute. Oh, sorry, my apologies. Other way around. If you can't eliminate, if you can't substitute, okay, unless it looks super easy to substitute, you typically stick with elimination. But let's start with substitution. So in this case, what variable can I start with? Either. They both work for me. Let's work with this one first. Let's say I've got 2x minus y equals 4. Let's just move everything around. So I get 2x equals 2, y plus 4. Well, actually, I'll just write 4 plus y. There we go. Are we okay with that? Are we okay with that?
Yeah.
Lovely. Now I'm going to divide both sides by 2. I get x equals to 2 plus y on 2. Okay? Lovely. Now what I'm going to do is I'm going to substitute that into this equation. Now, when we have simultaneous equations, we will move on to doing 2 variables, 3 variables later on in the year. But for now, we've got 2 variables, which means how many bits of information do we need? 2. I've got 1 equation, 2 equations, okay? So I need 2 bits of information to solve for 2 variables. I substitute that in, I'm gonna write, instead of writing x, I'm gonna write 2 plus y over 2. So I've got 2 plus y over 2 plus, now I'm gonna write the rest of it, plus 2y equals to negative 3. Are we okay with that?
No. And you have to put it in brackets first.
Does it matter in this case? No, so if it was 2 times x, then you're right, I would. I mean, it doesn't hurt to write brackets, you're absolutely correct. But in this case, I don't have to. Okay, let's simplify it. So 2 plus, let's leave it as, actually, y over 2. It's half of y, right? Yeah? Plus 2y. What's half plus 2? 2.5, easy. I'm just going to write 2.5y equals to negative 3. I'm going to add, so take away 2 from both sides. Take away 2, so I got 2.5y equals to negative 5, because that's negative 3 take away 2, right? So I get negative 5. Now I'm going to divide both sides by 2.5. Yeah? So get y equals to what? Negative 2. Are we done? Why not? Awesome. I also need to find x. So how do I find x? Easy. You guys are masters at this. I'm going to substitute this. Which equation do I substitute it into? Awesome. Doesn't matter. I'm going to substitute it into this equation. God, this is going to look disgusting. There we go. No, let's go this way. So I've got x plus 2 bracket negative 2, because y is negative 2, right? So instead of writing y, I write negative 2, so 2 times negative 2 equals to negative 3. So that means I've got x plus, what's 2 times negative 2? Negative 4, good. Equals to negative 3, and then add form both sides, I get x equals to 1. How do we feel about that one? So that was substitution, and I've just indicated that using a blue pen. Now I'm going to do the same thing, except I'm going to use elimination. Isn't technology amazing, guys? No? Okay. So I've got this equation over here. Elimination means I'm trying to cancel out certain things in my equation. So maybe I multiply something, maybe I divide something, whatever it is. In this case, it's easier to multiply. So I've identified, you know what? I've got 2y here, positive 2y, and I've also got a negative y there. What if I multiply the top equation by 2, and I get 4x minus 2y equals to 8? Is that the same equation? Yeah, if I put that in a calculator, or if I draw it or put it in Google, whatever it is, that will give me the exact same line. So it's the same equation. I'm going to go ahead and just rewrite this one over here. I get x plus 2y equals negative 3. Now, should I add or subtract the equations? What operation between negative 2y and positive 2y gives me 0? Add them, perfect, because I want to cancel it out. I want to get rid of one variable. Because it's difficult to try and solve an equation with 2 variables in it. Let's just get 1 variable. So I'm going to add them. I do realize I sound like a crazy scientist when I talk about maths. 4x plus x is 5x. Negative 2 plus 2y. Sorry, negative 2y plus 2y? 0. So I can write plus 0. I can just ignore it for now. Equals to positive 8 plus negative 3. 5x equals to 1. Awesome. We done?
No.
Why not? Awesome. Thank you very much. Always got my back. So I'm going to substitute it back into the equation. I'll put that over here. Let's say here. And I get x. Instead of writing x, I write 1 plus 2y equals to negative 3. Take away 1 from both sides. 2y equals to negative 4. Divide both sides by 2. I get y equals to negative 2. Did we get the same answers last time?
Yeah.
Yes. So no matter what method you do, if it's correct, you'll get the same answer. Now, what does this mean? If I've got x equals to 1 and y equals to negative 2, what does that mean? Yeah.
So Those are the coordinates where they cross over.
Lovely. That's where those lines will cross over and intersect. So when we learn about graphing, or not learn about, when we do graphing equations later on, linear equations, quadratic, whatever it is, when we graph those lines, whenever we solve them as